Question 17, we've got two trolleys, trolley A and trolley B. They are passing through two light gates, light gate 1 and light gate 2. Trolley A has a card on it, and when it passes through light gate 1, it should record the time it takes for that card to pass through that light gate. And trolley B doesn't have a light gate on it, a card on it, and when it passes light gate 2, the light gate 2 wouldn't even register that trolley B had passed it. But the context of the question will make everything clearer. So what they've asked is, state the measurements you would need to take so that you could determine the speed of trolley A before the collision. So what happens is trolley A is going to eventually collide with trolley B. So when trolley A passes through light gate 1, that light gate should help us calculate the speed. So from light gate 1, what we want to do is take the time it takes for that card to disturb the light gate. Okay, so that's one measurement. And also we want to find the length of this card as well. So this trolley is traveling at a constant speed v. So the distance, the length of the card divided by the time taken from the light gate would enable us to calculate the speed. So the measurements that we need is the length of the card and the time taken for the card to pass through gate 1. And then we do the distance, which is the length of the card, divided by the time it takes for the card to go through the light gate, and that will give us the speed of trolley A. Now, when trolley A collides with trolley B, they stick together. Okay, and that's what it says here. It collides with and sticks to the initial stationary trolley B, which wasn't moving before. So this hits that there, sticks to it, and then they keep on moving. So they both move at the same speed once they stick together. So that card will eventually cut across light gate 2, and that will then, you can repeat the same process again. You can find the time this card cut across light gate 2 once this trolley A and B are stuck together, and that's what will allow us to work out the speed. So we'll have the time trolley A went through light gate 2, and we'll have the length of the card as we've already got, and using those distance and time measurements we can work out the speed of trolley A, and because it's stuck to trolley B, that will be the speed of trolley A and B together. Now, the next part is explain how you would verify the momentum was conserved. Now, what we need to regurgitate is, what is the conservation of momentum? So the conservation momentum is the momentum of trolley A plus the momentum of trolley B before the collision, is equal to the momentum of the joined trolley A and B after the collision. Now we know this is the situation because they're joined together after the collision, so therefore the total momentum before should equal the total momentum afterwards. Now, and indicating what other measurements we would need to take, well, a momentum equals mass times velocity. That's not a measurement, that's a calculation. I've just written it there because I've said what the conservation of momentum is. So we've already discussed how we're finding the velocity of A and B. We've already talked about that. But now what we need to do is how we're going to find the mass. Okay, so the measure the mass of each trolley by putting it on a mass balance. And just to clarify, how we're going to find the velocity of the trolleys, it's the length of the card divided by the time that the card's in the gate. And with these measurements, we can find the momentum of each part of the collision before and after of each trolley A and B before and after. The last part of this question is, state and explain what you would do to minimize the effect of friction on the motion of the trolleys. One thing you could do is you can increase the angle, so to make the slope steep enough just so that the trolley begins to roll. Okay, at this point, what happens is you've counted the friction. Okay, so mg sine theta is equal to the opposing friction. So you've cancelled the gravitational force, cancels out the effect of friction. So you've accounted for it in your experiment. Okay, so when you push the trolley, when the trolley is moving along the ramp, it won't get slowed down due to friction because there's a component of gravity that's countering that with the slightly inclined ramp. Alternatively, you could use a frictionless surface like an air track, and to reduce the amount of friction, and that will, as a result, not decrease the speed of the trolley as it's moving along the track.